welcome to Cambridge, to the university, to the town, to Churchill College, where we are, and to this R&D Management Conference 2016. I'm David Probert, the chair of the conference, on behalf of the organising team, who are all wearing these yellow straps. So if you need help, please talk to them, and our International Advisory Board, and all our session chairs and reviewers, and everybody who's volunteered to collaborate in making this happen. A big thank you right from the start. We can't judge it yet. What we can say is yesterday for the welcome reception we had sunshine, and that was very pleasant, and that's by no means guaranteed, but we hope it will continue. In a moment I shall introduce Dr. Jeremy Klein, who's the chairman of RADMAR, the charity which is behind the R&D Management Journal and the conference, to say a few words of welcome. And I had intended to introduce Professor David Cardwell, who's the head of the engineering department here at the university, to say a few words before introducing our key speakers. Unfortunately, David contacted me early this morning to say he's in the A&E department of the hospital with his wife. Nothing serious, but he's very sorry that he can't join us today, and I will cover for his message. But before that, I'm delighted to welcome so many of you here who've joined us for this conference. It's the first time, to my knowledge, that it's been held in Cambridge, so thank you for coming. At my last count, there were 43 countries represented in our community here these 3 days, so a truly international mix. And we think it's the 40th conference in the R&D Management series. That's the best record we can find. Now, our theme, From Science to Society, Innovation and Value Creation. It took us some months as an organising team to come up with that. You can imagine it's probably one of the longest jobs is thinking of a good theme that resonates, and we tested it on our audience. You can make of it what you will. It's it can be interpreted in many ways, and I'm sure we will hear that during the conference. But at its roots, From Science to Society, Innovation and Value Creation, clearly deep in there is R&D and R&D management. And at its roots, this discipline has always been at the interface between theory and practice. When Professor Alan Pearson, who founded the journal and conference over 40 years ago at Manchester Business School, when he founded that activity, he based it on an active collaboration between university researchers and R&D managers in industry. So we really wanted to stay in that spirit, and we have a mix of academic and industrial contributions, and we hope to encourage a really constructive dialogue throughout the event by means of the varied keynotes that we have, also academic and industrial paper presentations. They've been highly selected. We were very oversubscribed. The workshop sessions, which are bit by invitation, and a very varied mix of activities on Wednesday afternoon, but also the social events, and that's where we hope the weather stays fine, and some demonstrations from our exhibitors. So this exchange of ideas is really the key to innovation. I think that's well understood, but also the value creation that arises from that, and ultimately improving all of our lives. So thanks in advance to all our contributors to the programme, and particularly our sponsors. We have a number of sponsors, as you'll have seen. The prizes given last night to the best poster, best posters, which are on display in the lobby by the PhD students, were supported by our sponsors. The key conference sponsor is Beko, who are a big domestic appliance maker based in the conglomerate Arçelik in Turkey. Very international business, who've just moved an R&D centre here to Cambridge. So you'll probably meet some of the Beko team in and around the conference. A little bit then just about the engineering department on behalf of David Cardwell, and I won't attempt to substitute his whole message, but he would have been very enthusiastic to welcome you here on behalf of the university again. He's a senior professor in the university, and on the part of the engineering department, which is actually the biggest department or faculty in the university. About 10%, I think, of the university is what we have in engineering. And it's very broad. It's a multidisciplinary engineering department, and that's a fiercely defended value within engineering. against the wishes of some of our colleagues sometimes to split off and do separate things, because it's how we teach our students and it's how we get multidisciplinary research functioning. The divisions have to be there because engineering is so broad, you have to structure into sub-disciplines, and they're imaginatively named A to F, and they cover all the subjects you might expect: civil engineering, electrical engineering, signal processing. We're Division E, which is manufacturing and management, and we take the form of the Institute for Manufacturing, which is where our organizing team are rooted, and we have a company wholly owned by the university based within our institute, ECS, Education and Consulting Services. You've met some of those team here, Joe Griffiths, our events manager, who've been hugely supportive in enabling us to put on this event. ECS is an interesting creation, worth looking at if you're involved in collaborative work with industry, because the academic team are very busy teaching and researching. To mount an event such as this, or to engage with industrial partners in dissemination, or even collaborative research, is hugely demanding on our time, but hugely valuable. And to have a supporting team such as ECS there to help us do it well is a real addition to our capability. We founded it within the IFM a few years ago. It was regarded as a rather unusual thing at the time. It's now grown to be very widely accepted by the whole engineering department, who's working on behalf of the whole engineering department and even the wider university. It, of course, is a commercial exercise, but it gift aids its profits, its surpluses, back to the university for research. So it's a very beneficial organization to have working with us. David would have wanted us to enjoy the occasion. He would have wanted you to network and discuss with all the mixed views that we have present, and it may be that if he gets an opportunity, he could join us later through the program. But for now, I would just like to hand over to Jeremy Klein, who's going to give you a little welcome and background to RADMA, the R&D Management Association. Thank you, Jeremy.
Well, good morning, and I'd like to firstly congratulate David and his team for the excellent start to this conference. As David said, we think this is the 40th in the series. The first R&D Management Conference started what was in 1980, and subsequent to then, there have been a few years with more than one conference. So as far as our records go, which they're not perfect, we do think this is the 40th. It's the largest ever R&D Management Conference. You can see here the last few years. It's been growing pretty much linearly since 2013, and many of the people who have contributed to those previous conferences are here in the room. I think the growth reflects two things. Firstly, the efforts of the organisers, and secondly, the fact that the field of R&D management remains an important and growing activity both for the society and for the economy. So we definitely are part of a vibrant and important community. RADMA is fortunate in that it is a part owner, co-owner of the R&D Management Journal, and as such, it receives funds from the publishers each year, and we feed those funds into 4 different activities. Firstly, we support the editor and the development of the R&D Management Journal. Increasingly, that's a team activity, and of course, all teams require resources. Secondly, we coordinate the R&D Management Conference series, both ensuring that the programme of conferences is known at least, 2 years ahead, if not more, and also trying to make sure that best practice is carried through from one conference to another. And Jonathan Aylen here has been editing a manual for the conference, which gets updated after each conference and then handed on to the organisers of the next conference. We fund PhD students and provide conference expenses and project expenses for research students in the field of R&D management. I know that several PhD students who are funded by RADMA are here at the conference, and typically we fund between 3 and 5 PhDs each year. And the final area of RADMA's work is in engaging with practitioners. And as David said, RADMA and indeed this field has always been practically oriented, but over time the link between academic research and practice has tended to fragment. And recently we've looked at trying to properly put something together that connects the practitioner community with academics. And Steve Bone here has recently led a team to produce a practitioner-facing website. And this website has got resources and information primarily aimed at practitioners, but probably will also be of interest to academics. We've organised the website into themes, 5 themes, and each theme is curated by the combination of an academic and a practitioner, both selecting material and providing an introduction. And we hope that this will grow to be a major part of our community. Here's the URL, and the website is something that we hope will grow. So please do contribute your ideas for resources, articles, papers. If you're holding a conference or a meeting, please tell us, we'll advertise it. And we'll also be looking to provide a facility whereby if you want to if you have opportunities for collaboration or you want to link up with companies or universities in whichever direction, then the website can be a starting point for doing that. So with that, I'd like to hope that you enjoy the conference and wish you all the best.
Yes, thanks very much, Jeremy. And you will have an opportunity, I think, to look at that website. It should be playing on one of our screens during the conference. Make good use of the IT support to the conference. You should have an app on your mobile, which enables you to see what's happening with an update, a live update in case of any changes. So just make sure you're keeping an eye on that. Right, now, my pleasure to introduce 2 eminent speakers to share their experience with us this morning. Warren East from Rolls-Royce and Joe D'Souza from AstraZeneca, starting with an unashamedly industrial perspective on the issues of R&D management, just to give us a sense of why we're attempting to work in this field at all. What are the issues that we need to address? Warren is a Cambridge chap, so we've been in contact in the past. It's a great pleasure for us to welcome him. Delighted that he's found time in a very busy schedule to come here this morning. He's the Chief Executive Officer of Rolls-Royce. He was appointed to the board of Rolls-Royce as a non-exec in January 2014. And he also served as a chairman of the Science and Technology Committee before succeeding John Rishton as CEO in July 2015. Prior to joining Rolls-Royce, and this is the Cambridge connection really, he worked for Arm Holdings here in Cambridge, joining it in 1994, and was chief executive from 2001 to 2013. So his topic this morning to share with us is Making the Future. I'd like to welcome Warren to the stage.
Thank you, David. Good morning, everybody. Yes, So the title, working title for this this presentation is Making the Future, because I think that's one of the things that R&D is all about. I'm an engineer by background. I was actually educated at the other university, but I've been in Cambridge a long time, and so now I don't actually mind who wins the boat race. I left university with an interest in engineering, and over the years working in engineering, I'd say that interest has turned into a little bit more of a passion. And a few years ago, I came up, for the purposes of a presentation somewhere, I came up with a definition, my own definition about engineering, and talked about taming science and nature for the benefit of mankind and society. So when David contacted me and talked about the title of this conference, From Science to Society, Value Creation in Innovation, then there was a real sort of resonance, and I thought, absolutely, this is what it's all about. Now, as he mentioned, I've only recently switched to mechanical engineering, having worked in the world of semiconductors for 30-odd years, and over the last few years I've also had the privilege of working on the board of Dyson, which is another company based around innovation and engineering. And so the observations that I make this morning are from across the piece. And in fact, you'll see some material here. This slide is Rolls-Royce headed slide, but you will see some slides with the ARM logo and an ARM footer on as well, because actually this material is drawn from experience in both of those businesses. And I make no apologies for that. In fact, some of the ARM material I did actually present in this very room over 13 years ago. So it's not that it's old material, it's just that truth tends to last. So the first question then is why do we innovate? And this is clearly from an ARM presentation. Why do we innovate? Well, it can be about solving an old problem in a new way. And of course, we're all sort of familiar with, over the last 10 years or so, Apple's approach to replacing lots of different magnetic tapes with first of all magnetic media and then solid state semiconductor media for storing music. The important thing to do here is not forget the missing link, which was probably the Sony Walkman, and I might remember to come back to that missing link a little bit later on. Another reason why we might want to be innovative is because, typically from a business perspective, we're interested in producing really world-class products and services because they win. And in a business, you want your products to be world-class, and they really have to be so if you're going to win, but also so that they attract attention. And I've used this image, even though it's an ARM slide, because actually the Rolls-Royce exposure to the aerospace applications. But another example might be relevant. Recently, some of you may have noticed that Dyson introduced a hairdryer, and the retail price of this hairdryer is completely mind-numbing. It's £300 or dollars in some parts of the world, about £300 for a hairdryer. I can go to Tesco and buy a hairdryer for probably less than £10. So why on earth would you want to pay £300 for a hairdryer? And the answer is because it grabs attention and it is truly a best-in-class product. So there's an example of some of the value, the incremental value in creating really world-class products. Another reason you might do it, this isn't quite the Dyson hairdryer, but this chap's very pleased, and notice the chap standing behind him, who's presumably done the job, is also very pleased. And I know that the engineers that we ask to work very hard on innovation find it hugely satisfying to see what they've done, and that creates enthusiasm, makes people innovate more, and you create a kind of positive, virtuous circle. Now, it's not just about products. When Arm started, then a key difference was the business model. And a quick recap for those who don't know, the Arm business model is about designing things, selling licenses to companies that use those designs, and earning money for selling those licenses, and then earning more money later on when those products get used and semiconductors get sold, and that creates a downstream royalty revenue. And it was a disruptive model for the world of microprocessors, and it turned out to be a very profitable model as well. And the picture and the image about wine is because it's really no different from what people have been doing with, or rather operating this business model is no different from running a vineyard. You plant your vines, and that's like selling licenses. And then actually, if you want to make a lot of wine, you have to really look after those vines. You have to look after them during all seasons. You have to look after the ground around them. And you have to spend a huge amount of time actually nurturing the vines. And companies like Arm, operating this business model, spend a huge amount of time creating a nurturing environment for their products to be successful. And that's one of the other themes that probably runs through. We're all sort of familiar with the R&D bit and the innovative bit, but actually making that successful in the commercial world, quite a lot of it is a bit like the vine grower. It's that unnoticed effort, the attention to creating an environment for the products to be successful. So lots of people asked me, after I left Arm, why on earth Rolls-Royce? And there are quite a lot of answers, but one of them is this. That's because actually it's a very, very similar business model. And what Rolls-Royce seeks to do is sell engines and plant them on aeroplanes and then provide as much of a nurturing environment as we possibly can for our customers to be successful with those engines and fly lots of people, lots of miles as economically as possible. And that increases our profit. And actually, it was quite a disruptive model when Rolls-Royce introduced it, and some of you may remember the phrase "power by the hour," which was essentially bringing that business model into the world of commercial aviation. So let's take a step back now and look at innovation and the benefits to society. It certainly does boost local economies. Rolls-Royce is based in Derby, and getting on for a quarter of our employees are there. Derby's a city in the South Midlands, and it has about 2.5 times the national average of skilled employees. And the industrial capability that's there attracts other advanced manufacturing businesses. And actually, Derby has the highest export value per head of any city in the UK, and that's at 3 times the national average. So Cambridge, we've got a little bit of work to do here. And it adds a lot of value to the local economy. It's actually been going for quite a long time. It also creates other businesses in the area, creates supply chains. So although Rolls-Royce only employs about 12,000 people in Derby, there are about 3 times that number of other jobs in the area, in the regional supply chain. Some of those people join one company and then move to another company, so the skills that you generate are transferable and you create a small ecosystem. Innovation enables companies within that ecosystem to move up the value chain. So if they can't compete, say, on labor cost with a competitor perhaps in another part of the world with different structural advantages, then that environment in which the company exists and the innovation that exists around it enables them to move up the value chain. And it does mean that we can benefit society as we look forward. So it employs young people, and for young people, if you look at our young people in the Derby area, for instance, then they earn about 40% more on average by utilising their skills at a company like Rolls-Royce than their peers. And so this is providing good jobs for young people. And that activity, that innovation that exists around there attracts investment from others. It also attracts investment from governments, and we can build on that and generate plenty of capability in the area. Now, I said it had been going on for quite a while. This is a picture, well, the picture on the right-hand side is our facility in Bristol, and the picture on the left-hand side is the same facility in Bristol over 100 years ago. And so making engines for aeroplanes and making aeroplanes has gone on in this location for quite a long time. And people say, well, let's create Silicon Roundabout, and then we'll just compete with Silicon Valley. Well, Silicon Valley's been doing this sort of thing for, over 100 years. Recently here in Cambridge, we produced a book celebrating 50 years of the Cambridge phenomenon. In fact, hard tech and biotech have been going on in Cambridge for, again, over 100 years. So this sort of thing doesn't happen overnight. Innovation is good. You have to nurture it, and you stick with it over a long time. Back to some Rolls-Royce examples. I mean, this chap's quite well known in the aviation industry, and some of his best-known work was obviously the jet engine which Rolls-Royce built upon. And over the years, we've done consistent, continuous innovation in jet engines to make them more efficient, consume less fuel, and so on. And there'll be more on that in a few moments. But it's not just about the engine design where we innovate, it's about how you use it. So those of you that might have read some newspapers lately, some of the newspapers have actually moved away from Brexit, and they're talking about things like an upcoming air show at Farnborough, and the picture on the right-hand side is the F-35 plane, which has vertical takeoff and landing. And that is a derivative, that is using Rolls-Royce technology, which is a derivative of the technology on the left-hand side, which dates from about 60 years ago, affectionately known as the flying bedstead, which was the first Rolls-Royce escapades in vertical takeoff. So it isn't just about the engine itself, it's about how we use the engine to make the product more effective and more innovative. Like many companies, we have an innovation strategy, and successful businesses are very clear about the importance of innovation. You have to value it, you have to encourage it, you have to go the extra mile to nurture innovation, because the very nature of R&D, quite a lot of what we produce doesn't work. Quite a lot of it, is blind alleys. So you have to be committed to it. You have to create an environment where innovation can really thrive, and then you can bring winning products to market. So there's a theme that runs through a lot of our products, which is around energy efficiency. Rolls-Royce is in the business of producing engines, and the engines that we produce burn hydrocarbons, and that's not very good for the environment. So if we can actually produce the same amount of useful power out of less hydrocarbon, that's good. And we do that in trains, aeroplanes, and ships. But this whole sort of innovation thing, I started thinking about it, and it's not confined to industry and what you might consider traditional manufacturing industries or high technology industries. I live just outside Cambridge, and there are vast fields. It's a very agriculture in the area around here is very arable. And so I looked at that sort of thing for imagery. Several of my friends are farmers, and what we do in the world of industrial innovation is very similar to what the farmers do. You spend a long time preparing the ground, and then sow some seeds, and then actually most of the year you spend creating that nurturing environment for the seeds to thrive as they develop. And over the next few weeks, then we'll be starting to see the farmers harvest. Hopefully, it's been a bit of a damp spring, and so maybe a little bit delayed in terms of ripening off. But that's the basic cycle, and that basic cycle is no different in the world of technology, manufacturing industry, and so on. So the mechanisms that we use are quite important, and let's look at some of the things that we use at the seed generation stage. So we provide an environment for people to exchange ideas. So on an intranet, an innovation portal, we have forums where people get together. We have people that go out of their areas into other parts of the business, into other engineering teams, innovation ambassadors. We provide resource and extra time for incubation and create special spaces and so on. So fostering innovation, enabling people to think about ideas, part of the commitment that I said is essential to make sure that innovation happens. As we move from the seeds into the nurturing phase, then we don't actually do it all at Rolls-Royce. Clearly, and by the way, I'm a firm believer in this, that 2 heads are better than 1, and multiple heads are even better, and different perspectives bring a better solution. So we work with a network of over 30 university technology centers worldwide. It's been going for 25, 26 years now, and that means that we have access to a whole load of external researchers with a slightly different perspective on the problem. And it's a continuous process, so we have people doing doctorates, we have that provides us with a source of useful people to come and work with us as well, and also a source of intellectual property generation. But the main thing is that it's augmenting in-house activity. It drives some rigor, it drives some additional challenge into what we're doing, and it enables us to scale in slightly different ways. And of course, we're not just about the design that goes on in universities. A company like Rolls-Royce has to make this stuff. Again, we utilize external resources to provide different perspectives and to leverage the investments of others and to leverage the brain power of others in doing this. So Rolls-Royce is an anchor business at the Manufacturing Technology Centre in Coventry, an anchor business at the Manufacturing Research Centre in Rotherham. The picture here on the right-hand side is a machine which enables the drilling of a very, very, very fine hole with sub-millimeter accuracy down a steel rod that's over 20 meters long, and that's quite a difficult challenge. But these guys are cracking that sort of challenge, and we're actually taking this concept of leveraging other people's effort, other people's resources together with our expertise, and we're taking that to other countries as well. So Rolls-Royce is now an anchor tenant with similar manufacturing research centers in the US and in Singapore. So that's some of the things that we do to nurture the. I wonder if we can go back. Yeah, to nurture the seeds. A bit like the farmer who's planning crop rotation, who's planning use of the ground over multiple years. So we're in a long-term business, and we have to take a long-term view of the markets. So engines that are here span basically on the left-hand side is state-of-the-art new aeroplanes today, and as we move to the right-hand side, we're moving out approximately 20 years or so. Now, this long-term approach has worked. If I look over the last 40 years, then those engines that are on the left-hand side, the newest ones today, are perhaps 25% better in terms of carbon dioxide emissions than their predecessors 40 years ago. They are about 40% better in terms of nitrogen oxide emissions, and they're over 20 decibels quieter as well. So you can actually live underneath a flight path, and it's not quite as bad as it used to be. And that's an example of what you get for long term. As we look forward, this industry signed up several years ago to reducing the carbon dioxide emissions compared with the year 2000 by 75% over the following 50 years. And as an industry, we're trying to compress that time line right now, because over the last 16 years, fortunately, awareness of environmental damage caused by these sorts of industries has increased dramatically, and so the industry is responding. And as an engine provider, we have a vital role to play in that. And over the last 16 years, so far, we've made approximately 15% improvement in fuel consumption, and we hope to, over the period, provide at least a 30% contribution to that 75% goal. So you have these sort of overarching ambitions of what you're trying to do, and you break it down into bite-sized chunks, and that's what we're doing. And then we need to look for innovation as we go in terms of how to achieve that. So here's an example. This is a Rolls-Royce 747. You'll notice that the engine with the blue fan is a little bit larger than the other ones on it. We keep the 3 ordinary engines on the plane just in case something goes wrong with the experimental engine. But this is an experimental engine, and actually the experimental bit is the blue fan in the middle there. And the blue fan saves almost half a ton of weight. So if we're going to make the thing use less fuel, then the first thing to do is make it lighter so that it uses less energy just to cart itself along. So that's a fairly obvious thing to do, but it's still an example of innovation. Rather less obvious is, when we get inside, how does the thing actually work? And squeezing the air more and making it burn hotter are two of the ways in which we can make the engines more efficient. And when we come to burning it hotter, then we have to get into the realms of innovation. So inside the modern engine, the temperatures are around 1700 degrees centigrade, and that's above the melting point of the steel that was in Frank Whittle's original engine. And it's a bit akin to putting an ice cube in an oven and expecting it not to melt. So you have to be quite innovative about that. Here's an example of what we've been up to. So Whittle's steel blade runs up to a certain temperature. Using different alloys enables you to run hotter still. Coating the thing with ceramic to shield the metal inside from the high temperatures of the air around it enables you to run a little hotter still. And then creating clever airflows by the holes that you can see on the surface there enables a layer of air, of slightly cooler air, to surround the ceramic to enable the thing to go hotter still. And each one of these steps is, of course, an innovation on its own. And because of the fact that it's sat inside inside an engine, it's actually doing some work, because that's what turbines do. Then, as well as having to operate in a fairly harsh environment, and I've just talked about the innovation enabling it to operate in that harsh environment, then it also has to withstand some pretty horrendous centrifugal forces, because it's whizzing around at over 12,000 revolutions a minute at 1700 degrees C, And so one of the things you need to do is make sure it doesn't fall apart. And although casting metals is a process that's actually been around for over 6,000 years, we're working, or we have been working on ways of improving that so you can actually produce this thing out of a single crystal of metal. So that's a story with some examples on successive stages of innovation to crack the overwhelming problem that we're trying to solve about making the thing more efficient. I've found that lots of engineering is about trying to make things more efficient. It's about trying to get a quart into a pint pot. And so here's a similar example from the ARM world. When you want to reduce the amount of energy consumed by an electronic circuit, one of the key things that you can do is reduce the voltage at which the thing is operating. But when you reduce the voltage more and more and more in a semiconductor, eventually the transistors stop working as you modeled the way they were going to work. And so the design eventually falls over. So the innovative step here that was taken at ARM was to say, well, hang on a minute. What happens when the transistors stop working and the design falls over? Well, if it's a microprocessor, it makes some mistakes. If we operate in a range where it only makes mistakes every now and again, then we have to remember it is fundamentally a computer. And so we can correct errors in the world of computing. And so there's a trade-off between how much power you save by reducing the energy and reducing the voltage, allowing it to make some mistakes, and then using energy to run the computer to correct the errors. And you find that actually, overall, you can win by using a small amount of compute power to correct the errors, and then for the rest of the time, the machine is operating at a lower voltage and saving energy. So a couple of examples there from both worlds of innovative steps. And it isn't just about the products. As we look forward to how products get used, then there's a sort of vast playing field of innovative potential as we look. And here's an example of some of the digital technologies as the world of aero engines is starting to sound more like the world of microprocessors as we adopt digital technology. Then there's huge potential for further innovation. One example of that would be in the field of unmanned ships. Many of you might be familiar with drones flying around, and some of those sophisticated drones are operated by the military, and they call them unmanned aerial vehicles. Well, here's an unmanned vehicle on the sea. By applying some of those enabling technologies on the previous slide to the world of shipping, then we can control the boat in its situation as the sea's tossing it around. We can control its position, and if you look up to several boats in a fleet, then we can optimize fleet management for the operator, and that can all be done remotely. Data can be about the ship can be merged with data about the weather, data about the tides, and the deployment of that fleet can be optimized. So let's switch back to how we manage innovation. Now we've done enough examples. How we manage innovation. So this is a slide that I presented some time ago because and it really does seem to be common in all engineering practice. It's all very well to ask your teams of engineers to be more innovative, but this is generally the response we get. Because actually, people have a day job to do as well. And the day job is normally pretty never-ending because we're always trying to get out the next product, the more innovative product, to be more competitive and so on. And there's a conflict between getting projects done and getting products out of the door, and sometimes those schedules come from, they come from your customers, and they're driven by a competitive environment. And cliches are cliches for a reason, so this is hard work. You know, the 95-5, the 90-10, whatever it happens to be, is there for a reason. And so what we need to do is try to optimize that balance to create a little bit more time for innovation. Or we can think about it a slightly different way. Different stages in a project. We do some R&D at one end, maybe some advanced product development, maybe some feasibility, initial investigation. Then we develop and test, and gradually the number of people involved grows. But the scope for innovation has this sort of shape. You know, as you increase the number of people, then you increase the scope for innovation. But as you get into the project, then there's less time available for innovation because we're actually trying to get that thing out of the door and stick to the knitting, concentrate on the day job. As you get to the end of the project, then the number of innovations that we find actually increases. Because the project runs into challenges, runs into real-world implementation problems. People have got their backs against the wall, and they have to get more creative to solve those problems. So we get bumps of innovation at the beginning and at the end of the project, but the scope for utilizing the innovation is gone down at the end of the project. And so, a bit like the farmer, I'll come on to that. A bit like the farmer, we have to create a way of banking the ideas. So the farmer has harvested his crop, but he doesn't sell it all immediately. Typically, he sticks it in a grain store like this and sells it when the market's right and sells it over an appropriate period of time. So what we need to do is create a sort of repository for good ideas and check the quality of those good ideas and enable them to move around. So you can check the quality with peer-to-peer review. An idea on one project might be useful on another project, and they can be passed around. And that then is the time when we get to actually cache the ideas, when we get to spend what we've stored away, and it's a bit like making bread products out of the grain, I suppose. It needs active management and it needs buy-in to create a percentage of allocated time to allow dead time between projects, to allow individual people to rotate off projects into R&D. And all of those things mean you have to make it important to the management. Management of the business has to believe in innovation. Where does the innovation actually come from? Well, here's the manager, and he's looking in the hat, and he's got a little bit of a perplexed expression on his face because, frankly, he can't think of the solution, and I can empathize with that. But the good news is that when you have a collection of lots of clever people, then the ideas actually come from all over. So when we're talking about management commitment, we need that management recognition that they don't have all the answers. The answers come from the people, and you need to create an environment to enable those answers to come through. So without reflecting too much on what I've been through, here's some observations from looking at this topic of innovation over multiple years. Necessity and sufficiency are two different things. It's essential to get over the bar to make your product competitive, but actually you only need to be sufficient. If you keep on going, trying to get higher and higher over the bar at a particular point in time, you'll never get the product out of the door. You'll never get the thing finished. So from a commercial point of view, it's important to understand the difference between what's necessary and what's sufficient. And similarly, you can create fantastic designs, fantastic products, but if you can't make them economically, then nobody's going to buy them. And so that doesn't work either. I mentioned the Sony Walkman right at the start of this talk. It's often better second time around. It was good, the Sony Walkman was good, but actually the iPod was better. I must admit, we found that the engine on the far left-hand side of that chart with all the aeroplanes, We've been through several iterations of that engine at Rolls-Royce. ARM products, a number of them are missing in the numbered sequence. Quite often it's better second time around with this, because you learn. You learn from being connected to customers, and sometimes customers aren't completely frank with their initial requirements. Sometimes they need to experiment a little bit with the first product and then get it better on the second product, but we can certainly do better by remaining connected with customers. I talked about the turbine blade. It makes the whole engine better. So we don't have to innovate across the whole piece. We just have to innovate in certain areas that make the whole product better. And that means that it is actually a tractable problem. I talked about business model. And the actual technology underneath and the businesses are inseparable. They need to work together. We've talked about customers. Typically, businesses operate in a slightly wider ecosystem, and actually, if you can work that ecosystem and create pull from other parts of the ecosystem, that can drag the customers along at the same time. There is no magic in this. It's applied common sense. The final two observations are that the best answers are often the simplest answers, and don't look to the management to come up with all of those answers. So that's all I had to say. I think we've got a little bit of time created for questions.
Thank you very much, Warren. As a gardener, I sympathise with the agricultural analogy. I just wonder what you've got to do with most of that's about dealing with the pests, though, I think. Right, we do have time for questions, and we have 2 roving microphones. So if you'd like, there's one up at the back. If you'd just like to say where you're from, who you are, and put your question to Warren, that would be great. Thank you.
Alicia Main from Simon Fraser University at SFU in Vancouver. I loved your talk, thank you. Fascinating insight into the way Rolls-Royce thinks about innovation. You talked a lot about engineering usually looking at things that are more efficient, and the process which you would look at for new product development when there was more efficiencies, whether it was less emissions or less sound, lower weight, for example. How about, could you walk us through how you would think about new product development at Rolls-Royce when the innovative idea, either externally or internally to the company, was not more efficient, but could be potentially on a different S-curve of development, or could potentially be a disruptive technology? How would you shepherd that, particularly if it was internal to Rolls-Royce? How would you shepherd it from the efficiency pressures as it's developing into its full state?
Well, hopefully everybody heard the question. It's back to the no magic, it's applied common sense. I mean, efficiency, I highlighted efficiency really to highlight the similarity between what we're trying to do in the world of jet engines and what the world of electronics is doing. But actually, if you look across engineering, it is quite a common theme. But there are other constraints. In our business, for instance, operational efficiency for our customers. They spend. Yes, they're worried about the environment, but they're also worried about their bottom line. And so, we can actually create better products for them in a sort of overall context by enabling them to operate more efficiently. So, for example, the boats, where we're really sort of targeting not just efficiency, but not just energy efficiency, but efficiency of operation for the commercial fleet owner. The same sort of thing can happen in airplanes. So I think you have to take a balanced, rounded view, and this is a fairly normal thing in that's the way human beings work. You're always trying to satisfy lots of different objectives, and there has to be a balance. We absolutely want to achieve the environmental improvements, and we believe that that's actually going to be better for people from a business perspective as well. But on the way, there will be opportunities to improve people's operational effectiveness. For instance, a lot of the data. I had a slide about sort of data technologies and use of data in the aerospace world, and increasing the amount of data, applying concepts, applying statistics, big data analysis. Then we can help improve the efficiency of operations.
Thank you. Any further question? Yes, there's one, Nitish, at the back there.
Ben Martin from Sprue at the University of Sussex. You mentioned the engine on the left having gone through several iterations. If I remember right, it began life as the RB211, a very radical innovation at the time, risky, very expensive, nearly bankrupted the company, but formed the success on which the company subsequently developed. I wondered if there are any lessons from that episode that Rolls-Royce have took on board over the years. You mentioned the need for being just good enough but not making it too expensive. Is this one of the things that came out of it?
Well, I have to say, being relatively new to the enterprise, I can't give you the explicit answer to that. But what I observe is that one of the lessons that's come out of it is an acceptance that improvements happen incrementally. And if at first you don't succeed, try again. So yes, that engine is a derivative of, or ultimately it's a derivative of the RB211 engine. Actually, the comment I made was iterations just around that engine design, where we tried to hit the goals of that engine, got them slightly wrong, tried again, and got it right. And I'd say that's a lesson that I've seen plenty of times before. I mentioned the ARM processors not having, some of the numbers are missing. So, you don't hear about ARM 8s. ARM 8 was a fantastic product, but it just wasn't quite good enough. But if ARM 8 hadn't happened, there wouldn't have been an ARM 9, and so on. So I think it's the same lesson. It's the try again lesson. But it is important, rather than just blindly trying again, to have a little bit of a rigorous analysis on why you think you really have missed the mark in the first place. And I think one of the differences between successful companies and less successful companies, having observed lots of customers over the years in a business-to-business environment using our technology to create their products, I would say the good ones are the ones that only get it wrong once or twice with each iteration, rather than the ones that sort of continually shoot behind the duck, as it were.
Okay, thank you very much. One last question there at the back, and then we'll need to move on. Melanie, just there.
Anna Salonen from the University of Turku in Finland. I just wanted to ask you a quick question. You mentioned the power by the hour concept, which Rolls-Royce is very widely known for. Can you share with us what proportion of customers actually would go for this kind of a concept, which is very untypical in manufacturing industries? So I've done quite a lot of research in the field of solution business, for instance, doing research with Wärtsilä, which is, I think, one of the companies that you're also familiar with. And they have a lot of problems with this types of performance-based contracting because customers don't want to go for it on a large scale. So is this power by the hour concept really working for Rolls-Royce on a large scale?
And the answer is yes, it is. Today, for our orders taken for engines today, and this year we'll take orders for getting on for 500 large engines. Approximately 90% of the customers take a power by the hour type contract.
Okay, with that, I'll have to close. I'm sorry, but thank you very much.
Thank you.
And Now, it's a great pleasure to welcome Joe D'Souza from AstraZeneca to give us another perspective on the industrial challenges of R&D management. Joe is the UK-US Product Development Science and Technology Lead of AstraZeneca. He's got 20 years' experience in line, project, and scientific leadership positions across pharmaceutical R&D in that business. In his current role, Joe is managing an extensive portfolio of science and technology projects that ensure that AstraZeneca's R&D capability maintains its world-class status for innovation and excellence in the delivery of new medicines. Particularly interesting company for us because they've just moved considerable resources from around the country, but to Cambridge. So there's also a big conglomeration of AstraZeneca R&D in the Manchester area, I think. So with the R&D hub that's historically been in Manchester and the R&D Management Conference this year in Cambridge, I think Joe is spanning both locations for us. So, Joe, over to you. Thank you.
So I'd like to start just by thanking the organisers for giving me the opportunity to talk about AstraZeneca here today and the experience I've had in the industry. I'd also like to thank the organisers for providing us with such a rich topic rich range of topics on R&D management. You know, when you look at the programme that we're presented with, you know, we start with the hard analytics. We move right through to the softer, more people-focused aspects of R&D management. So I'm absolutely sure there's something here for everybody, and I know I'm going to have some really interesting conversations and challenges, and I hope to leave here with lots of new ideas, so please come and talk to me. So, as David said, I'm with AstraZeneca. I've had around about 20 to 25 years in the pharma industry, and this is the talk I'm going to go through. I'm just going to give you a bit of context, if you like. Who am I? Who are AstraZeneca? What are we doing in Cambridge? And pharmaceutical R&D, what's all the fuss about? We make a lot of fuss about it. And then I'm going to go through various aspects of R&D management from my own experience. So it's a bit of a pick and mix selection from the topics that we're covering over the next 3 days. And then at the end, a bit of a summary and some asks of the audience. You know, we need your help. You know, I'm a practitioner when it comes to R&D management. There are lots of people in this room who are more theorists, and I think you can help us with the problems that we face. A huge amount of what I will say actually resonates so much with what Warren talked about in Rolls-Royce. I think you could have actually changed the logo on the slides, and I could have used those. So the commonality across our industries and other industries is clear for us all to see. So the view from the top of my mountain. I've got a slide on me because we all like talking about ourselves. But just briefly, my current role is Science and Technology Lead Pharmaceutical Development. So it's a fantastic role. I have internal and external responsibilities. Internally, my job is about developing the science and technology strategy for pharmaceutical development. And then engaging with our lead scientists, our most creative scientists, to make sure that they're aligned appropriately with that science and technology strategy to drive successful delivery of that strategy. As already been alluded to, these people are our most creative scientists and engineers, and they have the eccentricities that sometimes that brilliance brings. So our challenge is to make sure that these people really want to work for AstraZeneca, because if we don't provide them with the right environment, they'll go and work somewhere else. They might go to academia. So these are our leading scientists, and my internal role is around engaging those scientists in our goals. Externally, I work with a whole range of external collaborators, and also engage with various other funding agencies, for example, and other stakeholders. I'm a chemist by training, and I was also trained at the other place in Oxford. So I don't know what went wrong there, David, in the... And I just wanted to flag up that I've got some Portuguese heritage and also some English heritage. So, living in the UK is a very interesting time for anybody with a background like mine. Football is also a big topic right at the moment, and I'm married to a Welsh lady, so the match on Wednesday night is going to be particularly tense in our household. Okay, that's enough about me. I will go on just to give you the background about AstraZeneca. So, we're an Anglo-Swedish organisation. We've just recently moved our headquarters to Cambridge. And we're a huge enterprise. We're in the top 10 global pharma companies. Turnover is shown here. We invest a huge percentage of our turnover back into R&D, around about 19-20%, which is typical for a big pharma company. We've got a worldwide presence. Most of our R&D activities are in the UK, Sweden, and the US, and increasingly in China. We treat millions of patients around the world. This is the message from on a high in our organization. So our CEO is Pascal Soriot. He came to our company around about 3 or 4 years ago, and he changed the dial about how important science was to our business. We'd had a period where I think we'd lost focus on the science. We were focused on the commercial activities, maybe too much. Pascal came back, and for scientists, it was fantastic because he put science back at the center of the business. That permeates from the top throughout the organization. It's as a scientist, it's a great place to be now. There were times when it wasn't so good if we go back quite a few years. What we have as a blessing in a way is an opportunity to work on some of the most oppressive, if you like, disease areas that we've all encountered one way or another through friends and relatives. It's easy to motivate people to want to work against these sorts of diseases. So we've got a great privilege to work in this space. But of course it brings with it many, many challenges. Okay, our presence in the UK is huge. So I've just pulled out 2 figures from this slide. So 8% of total business R&D that takes place in the UK is AstraZeneca R&D investment. And then also, 1% of total UK exported goods are AstraZeneca products. So I only saw these stats probably about 12 months ago, and I knew we were big, but this really sent a message to me about some of the contribution we make. And this is where we're located, just briefly, in the northwest, and now also increasingly in Cambridge. And you can see in the northwest, where I'm based, at the Macclesfield site, we have around about 4,500 staff. Cambridge, we're currently growing, and I've got another slide on that. And here it is. So around about 3 years ago, a significant strategic decision was made to relocate a large amount of AstraZeneca's research capability to the Cambridge area. And the driver for that is to be part of what's been described, I think it's true, this vibrant biomedical ecosystem that exists in this, not just in Cambridge, but in the southeast in general. But the driver here is to be up close and personal, if you like, with these world-leading institutions that are involved in biomedical research. So we've got the Medical Research Council, Cancer Research UK, world-leading hospitals, and of course the university on the doorstep. And if you came in on the train from London, you will have come in along here somewhere. And this picture was taken some time ago, it's just fields, but what you will have seen are lots of cranes and a purple fence. Okay, so corporate colours are already here, and this is what the building will look like, and it's already starting to take shape. Round about 1,000 staff are already in the Cambridge area. They're not in this building, they're distributed across the area in anticipation of this building opening in 2017. So it's a significant and ambitious step to make sure that we have an environment to nurture innovation for not just the next few years, but for the next few decades and beyond, I'm sure. Just briefly, Macclesfield site, where I'm based, is just south of Manchester, very nicely located. And we're a broader setup, so I'm in this department here, so pharmaceutical development, which I'll say a bit more about in a moment. We have a number of corporate departments, and then we have a huge manufacturing capability at Macclesfield as well. And unlike Cambridge, we've been around a while. Not as long as your Rolls-Royce site in Bristol. Products that we make at Macclesfield, and in a way, I'm sure we've all pretty much used a Rolls-Royce product one way or another. We've all been on a plane and it probably had a Rolls-Royce engine. I kind of hope you've not used our products, which is a peculiar thing to say. These are products that treat all sorts of significant unmet medical need, particularly cancer therapies at this end, treatments for serious infections here, neuroscience products, statin, an ACE inhibitor, GI conditions. The one you may have used is this one, which is Diprovan. So this is the most widely used general anesthetic in the world. So if you've ever been under the knife, you may not have known it, but you had one of our products. So at Macclesfield site, we make about 2 billion tablets a year. So it's a big undertaking. So this is the department. I'm in pharmaceutical development, and we're a bridge between the research organization where active molecules are identified and the commercial organization where those molecules are actually manufactured as medicines. The things we do are we develop the synthetic route for the active agent. We develop the formulation and the device that the patient actually interacts with. You can think of digital technologies. There's huge opportunity in this space. And then we develop the manufacturing process that the commercial organization uses thereon in for the lifetime of the product. And then we are hugely regulated in our industry. So once we've launched a product with a manufacturing process, it's extremely difficult to change that. The barrier to change is huge because you have to re-register your manufacturing process across the world. So there's a huge incentive to get the manufacturing process as right as you can first time round because opportunity to change is limited. And I'll move on to pharmaceutical R&D. I can tell you about the dog later. So pharmaceutical R&D, what's all the fuss about? Well, the fuss is shown on this slide here. So this is a slide from the ABPI. And this shows the worldwide pharmaceutical R&D expenditure through the last 10 years or so. So total anticipated spend in 2020 for worldwide R&D is around about $160 billion. So that's the first thing that the fuss is about. And then in terms of comparison with other sectors, this is a UK slide now. Pharma R&D expenditure is huge, compared to other sectors as well. So, that's what the fuss is about. Why is it so expensive? I've just got one slide just to give you a schematic of the whole process. So the first thing you do is you identify your biological target that you want to engage with, that you think is relevant to the disease. You then identify an active agent that you hope will affect that biological process in a positive way. Okay? So you then have identified a potential active agent. And then you run through a whole series of activities around preclinical development, and then eventually you're into clinical trials. And then this phase 1, 2, and 3 clinical trials, increasingly expensive, increasingly complicated. And phase 3 clinical trials typically will be with thousands, if not tens of thousands of patients at clinical trial centers around the world. And this is all before you actually earn a penny. So this is all costs up front. So this timeline is 10 to 12 years is good for this. The cost, not surprisingly, is huge. Figures estimate, choose whichever one you wish. And I guess something which is depressing in a way, there's huge uncertainty through all of this process. So from here to launch, success is only about 5%. So the attrition rate is awful. The people I've worked with who've been there for longer than I have, longer than 20 years, they've never actually worked on a successful product. So that's what we're up against. And it's not just us, the industry faces this challenge, just in case you were wondering. Okay, so there's a few pictures to break things up. So I'm going to move on now to some of my own experience in R&D management. And I've kind of used the range of topics that we were presented with, and I've kind of selected the ones that I liked, and they're the ones I'm going to talk about now. And it's a real mixed bag. So firstly, I'm going to talk about tools, toolkits, and techniques. And these are the things that we hope make us better at making the right decisions in R&D. So the first one is quite a busy slide. This is all about improving project quality in research. And when you look at our attrition levels, it's absolutely essential that we stop working on projects as soon as we possibly can that we know haven't got the legs to succeed. And this was introduced to our organization a few years ago, and there's a paper on this. It's the 5 R's framework, and it really identifies at a very simplistic level the 5 key attributes that you really have to get right if you're going to have a successful medicine. And you should be asking these questions all the way through, not just at the end, clearly. And so it's all about making sure you've got the right disease target. You can actually get your drug to the desired tissue. You get it to the diseased tissue at a concentration and for a period of time that actually affects the course of that disease. It's all about the safety of the product, understanding the side effects, the toxicity profile. Is it acceptable to those patients that might be taking this to have a side effect? And that depends massively on the type of disease you're treating. You know, for a life-threatening disease, you know, people are the risk benefit ratio is different to if you're treating somebody who's got a headache. And then there's something about right patients. So there was a time in the industry when we just talked about blockbusters, where you would hope to come up with a drug that everybody would use, and it would be perfect. What we find is that, you know, we have to be much more selective about our patients. We have to identify those patients using appropriate diagnostics. We have to run our clinical trials in the right patient set so that you can demonstrate the effect you're looking for. And of course, there has to be a commercial justification as well. So this is something we introduced a few years ago. When it came in, you know, the number of projects in our pipeline reduced dramatically. Now, some people would say surely that's a bad thing, but it wasn't a bad thing. It was a good thing because we actually removed projects that had been lingering in the back of departments for many years that people hung on to, you know, hoping they would work out. And what we found was that, you know, sometimes the competition would get ahead of us, and even if we did successfully launch a product, we wouldn't be able to return an investment on it. So this framework has made a transformation of our portfolio to one where our attrition rates are improving from where they were a number of years ago. And that's so important. Okay, the next tool is around accessing more ideas. So we've had for a few years now an open innovation portal, and this is a kind of an invitation for anybody to come and talk to us about good ideas that they might have. You know, we're long gone are the days where we think we've got a monopoly on good ideas. So, you know, in here on the portal, we set out some of the challenges we face, and we invite people to come along and with their ideas. We also run specific competitions where we have a more specific question that we want to ask the wider community. So what this is doing, and it's early days yet, what it is definitely doing is it's bringing new ideas to the table, and we're working with people, collaborating with people that we probably wouldn't have been collaborating with. It would have been off the radar. So you know, interested to hear other people's experience of open innovation. The next slide is about clear priorities. So this is from my own department, pharmaceutical development, and you know, this is so simple. You know, we developed a set of science and technology priorities that were based on conversations within our industry, within the business, about the nature of new active agents coming through, the nature of how formulation technologies could improve products, the nature of the costs of manufacturing our materials and how easy it was for the commercial organization to actually successfully manufacture material. And then we just relentlessly banged on about this to anyone that's interested, both within the company and outside the company. So when we go to funding agencies, for example, this is the sort of information we share with them. These are the things that are important to us and our industry. You know, it just helps ensure that our priorities are very clearly set. So the other thing we've done is actually get a better understanding of what we're doing in science and technology. So again, this is a slide now which shows a portfolio of external collaboration. So again, this is from my department. And the size of the bubble indicates the spend in each area. So you can see straight away some of those science and technology priority areas are shown here, which is kind of some reassurance that we're spending the money in the right places. But you know, it just enables us to simply understand, see, and visualize, and report back to anybody that's interested what we're doing with the budgets that we have for external collaborations. This diagram shows the individual institutions that we're working with. So you can see Nottingham University, Manchester, Cambridge is on here, I assure you. And here you can see where we're spending our money. And here you can see how long, what's the duration of this collaboration. Are they short-term tactical things? Are they more strategic collaborations? So again, I'll talk a bit more about some of the collaborations we do later. And then this final one is around using a common language within our business. And none of this is new. I'm a bit embarrassed to stand here in front of you guys and talk about things that have been around for decades, in terms of recognizing that use-inspired basic research is what's important to us. What is very important to us in our industry. Using technology readiness levels to kind of willingly articulate to staff that some things are probably not going to work. This creates a culture where people feel supported if they are willing to try things, whereas in the past, failure was seen as negative, whatever the circumstance. People weren't rewarded for having a go. They were just, they were criticized for failing. So technology readiness levels is a language that helps us describe and evaluate activities. And it's powerful across a large R&D organization. So we work very closely with a sister organization in Sweden, and this enables us, and in the US, this enables us to actually have a conversation, a meaningful conversation about the activities we're doing. And then we're increasingly talking about manufacturer capability readiness levels. So if you can't make your product, you haven't got a product. Ultimately. So you have to start developing the manufacturing process alongside the technology if you want to be able to launch your product at the right time. Okay, so I'm now going to cover university interactions. So this is about driving a more strategic approach. And we've certainly looked, and we're learning, I think, from the aerospace industry where there's a much more strategic approach taken to working with the university sector. So, we, as an organization, AstraZeneca works with over 200 institutions across the world. And this is just a map of the UK, and it's wrong because I know for a fact we're collaborating with Hull University. It's not shown here. So we work with pretty much everyone. And just in our department, we've got around about 45 academic collaborations ongoing. We're even working with Oxford. So this is the direction we're driving in. We're moving from a kind of haphazard, led by individual champions, low priority activity, out of sight, modest, with abysmal knowledge capture. We would run collaborations for some time, and sometime down the line, nobody seemed to know what had happened in that collaboration. So we're moving to a point now where we're adopting a much more strategic framework, a more collaborative approach. So we'll do joint collaborations now with colleagues in Sweden, whereas in the past we might have been doing similar collaborations in the UK, and they might have been doing something similar in Sweden. And this is seen as essential for our long-term success. I don't think we're ever going to be completely over here. As I say, we're interested in people with good ideas wherever they are, but we're aiming to move in this direction overall. In terms of what we look for from our strategic partnerships, these are the kind of the obvious things. We're looking for expertise to help us with our challenges, complementary expertise. We're looking to inspire our own experts and enhance reputation for the quality of work. Not that many years ago, we were barely visible in terms of publishing our work. We've driven hard now to increase the number of publications we make and the quality of those publications. So we talk long and hard about high impact publications. That's a statistic that's monitored in R&D now. And that's important if we want to attract and retain the best talent. And equally, the strategic partnerships enable us to help guide and support training of individuals coming through the universities, whether that's at the undergraduate or postgraduate level. And then there's obviously the sharing of risk and better leverage. The challenge we face in this area is how to measure the success of our partnerships. And what we find is if we keep looking, we keep pulling up the plant to look at the roots, don't be surprised if it doesn't grow. You have to have faith, I think, in some of these things. And these are investments for the long term, and the investment will come if you stick with it sometimes. And these are just a few of the examples, again, from my department, pharmaceutical development, in terms of strategic partnerships that we're now engaged in, kicking off in the last few years, most of these things. So these all have, partner pharmaceutical companies involved in them. So, GSK, Pfizer are involved in many of these collaborations, clearly have academic partners, and they have appropriate technology business partners as well. The top two are around manufacturing technologies. Both of these have Cambridge University involvement. This one has significant Cambridge University involvement. And then the bottom three are more fundamental, if you like, science to core to our business: pharmaceutical science, analytical science, and advanced drug delivery. So this is the direction we're going in, a more focused, more strategic approach. We've had huge success already with some of these. So, for example, we've recruited, a healthy number of PhDs coming out of this CDT at Nottingham and UCL. Okay, there's the dog again. How am I doing for time, David? Okay. Right, okay, great. Okay. So the next one is on the sort of the softer side, the people, organisation, and skills side. And this, ultimately, for the business, this is about maximising the productivity of the expertise that we have in our company. And I'm going to talk about two things. And firstly, I'll talk about the being a successful ambidextrous organisation, and that's been alluded to already this morning. And then I'll talk about culture, connectivity, and direction. So, an ambidextrous organisation, what does that mean? So, an ambidextrous organisation is one that strives to achieve both of these kind of incompatible goals, if you like it. I think it's the Warren talked about this before. So you've got to deliver the current project portfolio. You've got to get those R&D assets through that pipeline and onto the market to bring you revenue. At the same time, though, you've got to invest in the machinery that's actually developing the future portfolio. So you have to invest in science and technology to improve our R&D machine so we deliver future projects in a better way. That could be faster, cheaper, better quality. And this isn't new. The ambidextrous organisation has been talked about for many years, many publications on this. We kind of realised that this was a challenge we faced, probably a bit later in the day than we should have done. But it's absolutely real, and it's tough to crack. So, we started to talk about this in my department in some detail, and we started drawing simple diagrams like this. These are the two tasks we're trying to achieve: deliver the current project portfolio and improve the machinery to deliver the future drug project portfolio. So ultimately, they're both about drug projects, and they're both central to pharma R&D success. The only difference is the timescale of return on investment. So this should bring you a return much quicker than this. If you don't do this, you probably haven't got a future. You won't be competitive as an R&D organisation. So we then developed this a bit further, and we drew it like this. It was like, wow, that's fantastic. Look at that picture. So, what this says is that really this is a continuum. They're both about drug project delivery. Where on this, if we think about this as a horizontal scale where you can move along based on what's important to you, you can probably think about where you as an organisation want to be on this scale. One of the challenges we face here is that you want your A team, you want your very best scientists to be doing both of these things. If you have a problem with a late-stage product that you're about to launch and you find you can't make it, you're going to ask your best people to fix it. Equally, if you want to develop a technology platform that will enable you to develop the future products, a different type of API, for example, active ingredient, you want to get your A team on that as well. And that's the challenge that our organisations face. You want your best people doing both of these things all of the time. So just exploring this a bit further, if an organisation spends all of its time here, if we as AstraZeneca spent all of our time here, we would be very successful at launching our products, but we would not be particularly good at improving the way that we develop future products. So we would be a bit more like a contract research or contract manufacturing organization if we operated at the left-hand side. Equally, if we're at the other end, well, we'd probably be a bit more like a university, dare I say, or a startup company where, you don't have any products. It's all around a technology platform that you're looking to develop and commercialize. So, we don't, as an organization striving to be ambidextrous, we don't want to be at either extreme. But where do we want to be? Where does AstraZeneca want to be on this continuum? But it's not as simple as that. It's not about where does AstraZeneca want to be. It's where does AstraZeneca research want to be, or development want to be, or manufacturing. And the answer to those questions will probably be different. And, the place you want to be now might be different in 3 or 5 years' time. If you've got a very busy late-stage portfolio, you probably want to pour more here. If your portfolio is looking weak, you want to pour more down here. So you have to be aware of this continuum and actively think about where you want to be. We took this one stage further. We actually talked to some of our very best scientists, and here are some of them. So in our department, we have probably about 50 principal scientists. And we actually sat down and we showed them this diagram, and obviously it kind of blew their minds. And we asked them these 3 questions. So, okay, Rob, you're a crystallization specialist. Where are you spending your time at the moment? Is it 50-50? Capability build and project delivery, or where is it? And then we did the same with these other guys, the analytical specialist or the device engineer. And there were fantastic conversations. Firstly, people thought it was a trap and there was a right answer, and if they didn't get it right, they were in trouble. But then they actually, most of them actually realized that we were starting to recognize the challenge they faced, because we were asking them to do both of these things all of the time. And these people are these are our A team, these people, not just these 3, all the other 50. So very fascinating conversation, very healthy conversations ultimately. And I guess the message here is that every R&D intensive organization has to recognize this. Maybe we were late to the party where this was talked about, but this is very real for us. We have to explain it and articulate it to our staff in a way that makes it meaningful to them. So recognize the challenge is real for R&D management. You've got to keep this interface porous, if you like. So if this is about future capability, you want to make sure that capability is coming into your projects, not in 3 years' time, but as it's being developed. You want to keep that interface porous. And you want your people to move along this continuum so that they spend time understanding the current challenges in projects and then can take that back and develop a capability that enables those projects to be developed in a better way. So the challenge we face, how do we decide where we should be and easily monitor where we are? We don't want to record lots of information. We want to do this in a smarter way if we possibly can. So that's what I mean by an ambidextrous organization. So I'm going to move on now to the other aspect here, and this is all about getting the best from our experts. It's the same group of people that we talk about. It's our A-team scientists. Lots of pictures on here. So I've talked at the start about how our new CEO, from 3 or 4 years ago, came to us and said, right, science is at the heart of our business. Science has been important to our previous success, and if we get it wrong, we're not going to have a future. So he very clearly set out this message that we've got to champion science, we've got to nurse it, we've got to be curious first and critical later. I think we become critical first. That's a rubbish idea, we tried that before, go away. We've gone to one of, that's an interesting idea. How can we make it better? And then maybe let's not do it. But there's a more openness, more willingness to hear ideas, both from within and without. So we've talked already about having a visible strategy, telling our staff what the priorities are, what we think is important. We engage people in talking about science all the time. This guy here is a maverick. So he's in the meeting room actually doing some chemistry just to make a point. Publicity all around the place. These are some of the publications from our department. Simple messages about basic scientific method, the engineering method. We publish much more extensively. We have simple prizes that we give to staff. And I'll just say a bit more about this top trumps thing, which was laughed at in many ways. But these key scientists we talk about, if you're working on a project and you have a problem, you want to know who can help you. Our organization changes all the time. We bring in new, younger staff, and we magically imagine that they're just going to know who our experts are because they've been there for 20 years. So we actually use this gimmick you know, a poster and some top trump cards to say, right, these are the people you should be talking to if you've got a drug delivery problem or a scale-up problem. And, you know, these are the things that we threw around the department. So, you know, Michael Metzler here is a device development and packaging expert. He's an expert in design of plastic components, et cetera, et cetera. He's also someone to talk to about German beer. So, you know, it's a bit of fun. It's a gimmick. But there's a really serious message here. These are real people. Some of them look a bit scary. You know, some of them have been, Jim looks particularly scary. He was robbed before. But, you know, so some of these people might not be that approachable if you've just joined the company and you're a new graduate. We want to make these people approachable, engaged and connected with the science that they do. So we just make it as easy as we possibly can. So the other thing we talk about is connectivity and the need for T-shaped scientists. Okay, so our business, our challenges we face in pharmaceutical R&D require the skills of all of these experts and many, many more beside. And I will certainly have offended some of my colleagues by not putting them on here. But, you know, what we need in each of these is huge depth and expertise. So these are our I-shaped scientists. We have to have depth in all of them. But equally, if we only have these folk, we end up with fantastic biology, but we probably don't end up with the chemistry that responds to the need for that biological target in the right way. So in addition to having, you know, I-shaped scientists in all of these, we have to have a healthy number of so-called T-shaped scientists. So these are the people that have got depth. They've come to us probably with some depth, but then we've targeted them. We've identified the people with the biggest potential to broaden out as well. So there can be the translator, if you like, that ensures that the biology problem becomes a meaningful problem for chemists to actually help with, rather than just something they don't understand that hopefully the biologist will sort out. So, you know, we need and we have and we nurture these T-shaped scientists. We don't, you know, but don't get me wrong, if you start to become a T-shaped scientist, well, you're maybe not quite so hot in the eye. You know, you lose something probably. So what's the right balance of these individuals, the depth and the breadth? Okay, so the next one is, it's about these experts. It's about giving them the space to make mistakes, giving them some breathing space. And someone pointed this out to me. One of my colleagues said, you know, Marianne, she's a bit like a bee, isn't she? You know, you never quite know which direction she's going to go in. But if you step back and watch her over time, she'll move to somewhere good for us as a business. For heaven's sake, don't try and keep tabs on her all the time, because you'll drive yourself mad, and you'll drive her mad. So, you know, a swarm of bees has purpose and direction, but you don't all need to be in perfect sync, and they do random things. Don't try to keep track of them all the time. The scientists, our best scientists, are exactly the same. Give them some purpose, give them some strategic long-term goals, and then step back and give them some space. Create a climate that brings new interactions between disparate groups. So get the theoretical physicists talking to the biologists. You'll be surprised what comes out from those conversations. And generally speaking, we're usually pleasantly surprised with where our experts end up if you give them that space. And as I say, if you don't give them the space, then probably leave. Okay, so finally, pharmaceutical R&D. Hopefully, you've got an understanding of where I'm coming from, what AstraZeneca is about, what we're doing in Cambridge. You'll hear and see more and more about AstraZeneca in Cambridge. You know, I've even seen adverts on bus stops for AstraZeneca in Cambridge, which really quite was surprising. You know, challenges in our R&D world are complex, etc. It's cost, attrition, particularly tough. Timelines. We are highly regulated. I've not really talked much about that. We want to collaborate with anyone with a good idea. You know, we've got a great advantage in how easy it is to motivate people to work in our industry. We should remember that. And R&D management more generally, you know, it's not a place for a quiet life. You know, it's complex, it's tiring, and if you think you've got it right and everything's perfect, well, you probably won't have it right for very long. You know, you have to continually look to improve. The point was made, I think, right at the start by David about R&D being a critical resource to be managed for societal, environmental, and economic benefit. We hope through our efforts at AstraZeneca and the pharmaceutical business is generally that we're hitting these targets. Some asks of the audience, and I think I've covered most of these. So I'll probably just leave it there. And just a few acknowledgements. So a number of people that helped me with this presentation. David for introducing the concept of ambidextrous organisations, and that term, certainly. So many colleagues I've worked with over the years, it's hard to mention them all. So thank you for your attention.